Jamen, klokken er ved at være 5, og vi er klar til det her webinar med Ralf Buechler. Vi har glædet os til det her, og jeg vil lige starte med at give en ganske kort teknisk introduktion til vores system her til jer, hvorefter at Flemming han kommer og introducerer Ralf, og så kommer Ralf selvfølgelig på, og til sidst vil vi have masser af tid til spørgsmål. Det er jo i det her system sådan, at I kan ikke tænde jeres kamera, I kan ikke tænde jeres mikrofon, men I kan stille spørgsmål under det, der hedder Q og A. Så hvis man klikker der, så åbner der et vindue op til højre, hvor man så kan skrive spørgsmål. Desværre har vi ikke rigtig kunne finde ud af, der er nogen kan godt få deres navn på, men ellers så må I meget gerne skrive jeres navn på, når I stiller spørgsmål, så vi har en fornemmelse af, hvem det er. Det er ikke noget krav, men det er altid rart at lige have en fornemmelse af, hvem det er. Jeg kan også sige, at der vil være tekstning på, og den her tekstning, den har også automatisk oversættelse, som selvfølgelig godt kan være lidt besværlig, men op til højre, eller øverst op til højre, der vil der være burde der være en knap, der hedder noget med billedtekster, som man vælger at slå billedtekster til, live undertekster, og så kan man vælge sproget, hvor man så skal gå ind og vælge det til dansk. Og når vi nu snakker dansk, så bliver der værre råd, fordi så tror den, at vi snakker engelsk og prøver på at oversætte det til dansk. Så det skal man virkelig ikke gøre. Det er kun forvirrende. Så skal man slå det fra, hvis vi begynder at snakke dansk. Men når at det går over til det engelske, så hvis man har behov for det, så kan man altså slå de her undertekster til. Man kan faktisk også pause det og nederst til venstre, men så kommer man selvfølgelig bagud. Der er i forvejen en lille bit smule forsinkelse, og så bliver det selvfølgelig lidt rodet, men det kan man gøre, hvis man skal på toilettet, eller man skal ud og hente en kop kaffe, og så bliver der bare lidt forsinkelse på. Vi optager det også, og vi sender jer et link med optagelsen bagefter, eller i morgen sikkert. Så der er mulighed for at se det igen, hvis det skal være. Men jeg tror, det var det. Eller er der noget andet, Flemming? Kan du?
Nej, det var fantastisk.
Ja, ikke? Så
Alt det
giver
teknik.
vi videre til dig.
Ja.
Yes, så hopper jeg ud.
Velkommen til alle sammen. Vi er 121 mennesker nu. Jeg vil lave sådan en dansk-engelsk introduktion helt hurtigt her omkring Ralf Buechler. So dear Ralf, first of all, welcome. Good friend of Danish beekeeping. We have known you since ever. Last time you were here, we talked about when we met first time, and it was actually in Denmark. So it was really nice. And this is about a project that we call Development of Sustainable Danish Varroa Strategy. Og on Danish, you could say, udvikling af bæredygtig dansk Varroa-strategi. And it's very much, this project really came up in a cooperation or a talk with one of our queen breeders, Kim Jacobsen, so thanks a lot. I hope he's here today as well. And the idea is actually that we have a strategy. We have our treatment methods, and we're pretty happy with them. But we also can see that our methods are getting more and more difficult, and we see more and more problems. It could be because of climate changes or something like that. And it's time to move forward, simply. So we have our packets, our Varroa treatment methods, and they actually work pretty well. So if you want to stay there, do that. But we want to encourage our beekeepers to move forward. And therefore, we have invited Ralf Buechler because he's been working with Varroaresistens for ages, and are a pretty famous person within Varroaresistens society network in Europe. What we try to do in this project is that we had 2 workshops, the 10th and the 11th of December, I think, where we invited Ralf and a closer group of beekeepers. And you could say the headline was really, how can we start this? What are the needs? And of course, we took the inspiration in Ralf. And it was 2 really good workshops. I have to say the one in Sorø was really good. But then we talked in the car and on the way to Vingsted, and Ralf, he said, yeah, we should then. And that really means that together with 40 participants, the one in Vingsted actually became extremely good and very inspiring about the needs and how we can do and what the beekeepers they need, how to kind of start with it. In this project, there are other things running as well. Some of you know that we have developed this Varroa model, varroamodel.dk. Please, everybody, go in and play with it. And you also know that we have our high block program, stedekot.dk, and we have money there to develop it and fit it into kind of a breeding situation. And today, Ralf, together with you, we thought it could be really fun to invite a bigger audience like the ones that we were working with, collect some experience, and then we simply ask you, come and make your talk again. And maybe you're moving a little bit in different directions. Now we have met the Danish beekeepers and our speculations and our concern and so on. So Ralf Buechler, welcome. I'm very happy that you're available and the floor is yours. I'm really looking forward to your talk. And we have to say sorry at the end. This talk is going to be maximum, let's say 1.5 hours. Because Ralf, he has another appointment at 7 o'clock somewhere. And I think it's good that we focus and that we simply keep it, so to say, short. Otherwise, we could discuss all night long. Ralf, welcome.
Yeah, Fleming, thank you very much, and Ole also for the kind invitation. And in fact, I have to say it was a big pleasure to meet many of your colleagues in Denmark months ago. And we had very good discussions. And as always, one learns from each other. So I went home and was very satisfied. And for today, situation is slightly different. As you already said, we are limited in time. So Ola actually asked me to keep the talk maybe about 45 minutes. So I shortened it, and we will have sufficient time to discuss things. So please feel free if you misunderstand or don't understand fully what I mean at certain points or have additional remarks. You're most welcome to put them in the chat, and we can go back to this, and hopefully I can answer the most important questions at least. And yes, it's my personal interest to help you in this respect. I will start with a few words on my personal situation, and that may better explain why I'm here with you and happy to give this talk. I'm myself keeping bees, since nearly 50 years now. But beside the practical beekeeping, I got the chance by study of biology, agriculture in Bonn to grow into the field of bee research. And then I was happy to lead this bee institute in Kirchhain, which is one of the bigger German bee institutes dedicated to practical questions, beekeeper training, pathology lab and those things, but also with good resources for research activities. And we run about 300 colonies at the institute, and most of them were involved in our breeding programs and our investigations on colony management and such practical aspects. And I did this for quite a long period until I got retired 3 years ago. But I'm still in touch with many colleagues from the research network. And I'm also involved as advisor in the German Bee Breeder Association, which is called Arbeitsgemeinschaft Toleranzzucht. And now with some more freedom for my private activities, I took the chance and registered myself as a breeder, which means I run now about 25 colonies and do very systematic testing and inseminate my own queens and those things which we understand as breeding activity in a core sense. But with today's talk, I would really like to reach out to all beekeepers. And I may say this already in the beginning, when we want to develop in the direction of a more resistant bee population in our countries, then it's not only a question of breeding activities by a very small number of registered breeders, but it's really a challenge for the whole beekeeping community. And in this sense, this wider sense of breeding, all of you have some obligation, have some responsibility for what is going on in the selection of bees, and how susceptibility or resistance will develop within the next few years. And hopefully I can get this a bit clearer by my talk. So let's start with a promising point, and this is, we see by now that there are quite many highly resistant Apis mellifera populations throughout the world. And this evolved in the last few decades. Here on this world map, I show some dots which stand for well-studied populations where we have other scientific publications, and can be sure that bees survive well over many generations without bee treatment activities by beekeepers. And things are moving forward, and meanwhile we can say it's nearly all of Africa, most parts of South America, and even bigger parts in Middle America don't know any chemical treatments against Varroa anymore. So this clearly shows resistance against Varroa is not just a theory, but it's existing, and it seems to be the natural way. If bees can freely develop with this parasite, then earlier or later they will develop resistance. And of course, it's an interesting question. How can this happen so quickly? Because we see usually within about 10 years' time, resistance can be there. And from all the research done in the last decades, we now better understand what is going on. And so we should start with the better understanding, how is natural selection on resistance working? I'm a bit unsure if you how much delay is between what I'm talking and the slides you see. Ole, maybe you have to give me advice if the slides come much later.
No. I think it's okay.
It's fine, yeah.
Yeah. Fine. I think it's just if you're looking on your mobile phone, I mean, there's a delay in what the participants are seeing.
Yeah, that was confusing me. So okay, thank you. To better understand how natural selection is working, and first of all, easy to understand. If beekeepers don't interact, then it's only strong surviving colonies which will swarm the next season and which can propagate. So this is, let me say, on the queen side. But under natural selection, it's even more important to keep the drone population in eye. And main selection probably is done on the drone side. And this is based on a huge surplus of drones, and we have 10,000 of drones available in an area, and they all meet within congregation areas. And queens go there and get mated then from just a few of them, which are under extreme competition within this competition, in these mating areas. And what we also see is drones are extremely susceptible to many diseases, and specifically to Varroa. So if there's a Varroa mite present in a drone pupae, the emerging drone will be marked for the rest of his life. About 50% of those drones are not even capable to fly, and those who can, they have shorter flight durations, they have a shorter life expectancy. And if one of those poor guys ever achieves mating success in this strong competition, then it won't be of a smaller effect because they have a very much reduced a number of spermatozoa. And this all go together with the haploidy of drones, which means they only have a mother. They don't have mother and father as female bees have, or as all of us have. And there's one big advantage of such a haploid step in the propagation process. And this is at the moment where you have a haploid organism, he can't hide negative alleles behind the better one which he got from the other mating partner. That means whenever drones show a genetic weakness, they are definitely out of the game. And in nature, this is used to have a very strict selection on resistance. And this goes hand in hand with the multiple mating of queens, which means the queen mated with 15, 20, or even more drones in the usual open mating process, takes home a good selection from the best colonies which are available in the closer surrounding. And this is the mating system, and it's really designed to optimize the selection on vitality. So this is what happens in nature, and this is what guarantees that within a few generations, a susceptible colony population can switch into high levels of resistance and treatments are no longer needed. However, we see the situation in our intensive beekeeping situation is still different. And of course, varroasis is still very harmful. And the question is, what happens there? How do we, in the way how we keep our bees, successfully prevent the natural development of resistance? And there are several points, of course, but two of them may be most important. And one very challenging thing is winter treatments, because it's the application of winter treatment which at the end ensures that even highly susceptible colonies can survive, can propagate the next season, and even more important, that they still can contribute to the drone population. So it's simply the winter treatment which enables susceptible colonies to pass on their negative genes to the next generation. That was not foreseen under natural conditions. So it's our treatment concept. And the second point is of similar relevance. We learned that we can get better honey harvest from colonies which do not swarm. We want to keep them as strong as possible. And this is why we select on low swarming tendency and why we use swarm prevention techniques quite successfully. But the consequence is we get a very continuous brood production over very long periods, from early spring, all summer through and until late autumn maybe. And this is the basis for this exponential mite population growth, which happens in many of our colonies and which is not happening in the same way under natural conditions. So those 2 points are very serious, but it's aspects which are in our hands. So we get a chance as beekeepers here maybe to adapt our management concept, and this is what I want to look deeper in now with you. So let's start with this Varroa population development. And here on this figure, you see a standard brood curve starting early in the year. Now with these mild temperatures, colony may probably start rearing some fruit already, and then at the moment where foraging activity starts, of course, the curve is steep going up, and then in the usually last few days of May, we reach the peak with maybe 35,000 fruit cells, and then during summer season, it's more or less continuously going down until fruit interruption then during winter. So this is quite normal in our region and also for Denmark, I think. And what happens with the mites, and the strong curve here shows the fruit infestation level as a result of the number of mites in the hive present and distributing on the given amount of fruit. It starts on a very low level because those colonies here were successfully treated in winter. In the model, we started with 40 mites overwintering. So it's a very low infestation in early spring, and it stays more or less stable on this low value in the period while the brood is still steeply going up and mites can't grow so far. But you all know what happens. Mites, without any influence from outside, can easily double its number within 3 to 4 weeks' time at the moment where young mites can immediately go to the next brood cell and can propagate again. So within 3-4 weeks' time, we get double the number of mites in the hive. And this at the end results in this exponential growth curve, as you see it here. It's not continuously going up, but it's getting steeper and steeper upward. And this is the main challenge for our treatment activities, because at the end, it's really exploding. And you see this upper part of the graph I colored in red, because once we come close to this 10% fruit infestation level or go even higher, we have clear consequences for the colonies. If it's just 2, 3, 5% fruit infestation, the 95% of bees which emerge uninfested, they will do the job. So the colony remains strong and you have a normal honey harvest, and you probably even don't recognize that mites are there. But once you come to this 10% or higher fruit levels, then you will probably detect the first bees with twinkled wings. You may see mites from time to time on the bees. And at the same time, you see how steep it goes up. It's then only a question of a few days, few weeks until the colony will collapse. And this comes together here from the period of the year with the start of the winter bee breeding period, which is about here in August, September mainly. And this is the most critical period, because winter bees, if they don't develop without mites and viruses in the cell, they will be with a short life expectancy. They are not capable to really overwinter and start then as a strong colony in next spring. So what we learned is, and this is the advice which you got in Denmark, just the same as in Germany, as soon as you run your last honey harvest, which is most regions somewhere in July, latest early August, then please treat as soon as possible with a suitable summer treatment, which for most of us is formic acid or oxalic acid nowadays. And what we can achieve is that we clearly reduce mite infestation levels. So it's very useful to do this. And with those treatments, we are more or less able to keep the mite infestation levels clearly under this 10% threshold line. But at that time of the year, we are not capable to reduce mite loads to close to zero, because most of them are well protected inside the brood and so on. So what we do in addition then is that we also run a winter treatment. And there's a huge misunderstanding about this winter treatment for many beekeepers. Most or many beekeepers believe that by the winter treatment they can improve the winter success of the treated hives. And this is absolutely wrong. It's just the opposite. The winter success of those hives is decided much earlier here in this period where the winter bees develop. So if you kill hundreds and thousands of mites somewhere in November or December, it's too late to improve the health situation of the bees. But it clearly shows there was high pressure in the period when those bees developed, and the consequences, they have a short life expectancy. So the colonies will get weak or even die during winter. And so finally, the main reason why we recommend winter treatment is just as a precaution with regard to the next season. If we don't run the winter treatment, then of course we start here on a higher level with the spring development, and that means in consequence the curve would go like this, and we may reach this critical threshold of 10% fruit infestation in a period where there is still honey flow going on and where we can't use chemical treatments. So to really understand what is going on here, we are forced to a winter treatment which is harmful to the bees because we can't treat in time during the main season. So let me put together the weak points of our established treatment strategy. Then first of all, you have to say the summer treatment often comes too late with regard to the number of mites. And secondly, at the moment where we use these acids, their action is quite weather dependent, especially formic acid, and in this sense, it's not always a very reliable treatment. And then the next very important point is we can kill mites with those acids or even synthetical summer treatment drugs, but we don't kill viruses. And once we reach high mite levels, we can be pretty sure that we also get high virus levels. And if we come too late, then we may still in time kill the mites, but we have these high virus levels. And that means also in consequence, and that we don't can rear healthy winter bees. And further on, acids are in general also harmful to bees. Formic acid is really a challenge for bees, and also oxalic acid shortens life expectancy and has negative effects on the colony in general. So, and finally, with this treatment concept, we are really forced to have this additional winter treatment, which in itself doesn't make sense to improve the health status of the colony, but which we have to run with to make sure that our chemical treatment comes still in time during the next season. So that's the starting point where about 20 years ago at the Institute in Kirchheim, we said, well, it's a stupid situation. How may we improve this? And we always like to go back to nature and first of all to better understand how do bees protect themselves in nature. And that's why I show the picture here of a swarm and want to explain you what happens at the moment where we allow colonies to split as they usually do under natural conditions. So they use this steep upward development and the strength which is achieved then somewhere in May to split, which means the queen goes out with a big portion of the adult bees, leaving back part of the adult bees and all the brood which is there. You know the swarming process. What happens then in the sense of brood activity? The old queen stops egg laying a few days before she goes to swarm. Then the swarm goes out. He has to find a new cave. He has to build the new combs. So it takes some days before there are cells available in which queen can start egg laying again. And then it takes 3 weeks time until the first brood emerges. So that means for such a swarming unit, there is at least 4 or 5 weeks without new bees inside the hive. And exactly the same, sometimes even with the longer brood interruption happens to the left back colony, because they have to rear the queen has to develop first and it has to get it sexual mature and has to mate, and so it takes 4, 5, 6 weeks sometimes for those units to start brood production again. And this is what is regarded here. So brood interruption means there's no chance for the mites to propagate in this period. It means all of them come back to the adult bees, and on the adult bees, many of them die with foraging bees in the field, with grooming activities on the bees, and so on. So you have a natural mortality of 1 to 2% of those mites every day, which means that with 4 weeks brood interruption, you lose 35, 45% of the mites, and the rest is split. And the remaining mites, there something interesting happens. They will go into the brood again when the colony restarts brood activity. But what we observe is that within the first few generations of brood activity, they don't have normal full reproductive capacities. And that has something to do with the feeding of the mites. They really change activity, and that means with such a brood interruption we have a long-lasting negative effect on the further mite development, and the consequence is shown here. Without any treatment, without taking out any mites, the infestation curve is set back and may reach later the season this critical threshold, but usually not within the winter bee development. And in general, you have much healthier winter bees here in such a system. So this is what we recognized. And the idea was now, if our mite problem is mainly a brood problem, then please let's go to a more natural way of brood production and have a brood interruption. And those techniques were developed not only at the Institute in Kirchheim. Meanwhile, it's a worldwide activity, and many of those techniques are very well studied and proven in the meantime. And here now I want to introduce them to you to show there are different options. And one of those should fit for each of you, but there is not the one solution which is perfect. It's something where you have to think about and see what is fitting to me, to my knowledge, to my goals, which I follow, to the number of hives and so on. And I will quickly describe the differences. So the first technique can be called total brood removal. And this is like in swarming. We come at a certain date and we split the hive. But in this case, it's not the old queen and bees which go out, but we take out all the brood. And of course, we can't do this too early. Immediately after this measure, no young bees emerge for the next 3 weeks in those hives, so they get weak, and that's why we recommend to do it just a few days before the final harvest. Then you won't have a negative effect on your honey harvest. But if you do so, you don't have to use any chemicals to get rid of the mites, because at the moment where all the brood is gone and you leave back a single comb with some open brood cells which get sealed before the queen starts egg laying again, and new brood from this new egg laying is getting sealed, 75-80% percent of the remaining mites will introduce this one comb, and you can take it out like a trapping comb, and then you are done with this hive. So no chemicals, no search for the queen, because you can simply brush off and shake off the bees. Just make sure that all the bees together with the queen remain in the original box. And then after removing the brood, you add empty combs or add wax foundation, and you will see that they easily recover within 6-8 weeks time. They will be as strong as colonies where we haven't taken any brood. And of course you can use the removed brood to build up additional colonies. So this is really an interesting and excellent way for small-scale beekeeping, where you want to have some propagation and want to avoid any kind of chemical treatment. The negative aspects is it's quite laborious, because you have to take every single comb. You need additional boxes to take those combs which you remove. Maybe if they should emerge, then bring them to a separate place, and so on. And the second aspect is a more natural one. At the moment where you take all the brood and just leave back the queen and adult bees on empty combs, then of course they have to collect pollen in the next few weeks to develop into a strong colony. And this is a question of your location and of weather development and so on. But just be aware, this is the critical aspect. As I said, this is maybe excellent for small-scale beekeeping. There is the alternative for large-scale beekeeping, and this is to put the queen simply in a cage, which is constructed in the way as you see it here in the picture. It should be mounted inside a comb, so 2.5 centimeters thick, that it fits inside the comb, and with queen excluders at least on one side or even on both sides, like in the shown example here. And there you put the queen in, and as you put the comb back in the center of the hive, all the bees going up and down the bee gaps will run over the cage, and worker bees will easily pass the queen excluder and touch the queen and go out again. So you can be sure that the queen pheromone is present all the time in the hive. The hive feels queen right, and also the queen is well cared by the bees, so that she will easily start egg laying again if you release her sometime later. And sometime usually means about 25 days. You want to be sure that all the brood is emerged until you release the queen, because at that moment you combine it with this one-time oxalic acid treatment. And that can be done by evaporation or by spraying or even by tripling, just as you like, and as it's easiest. But if all the mites are on the bees and you have this one-time treatment, you get 95% or even more of the mites. And so this can be done then maximum about these 25 days before the final harvest. You can't treat with chemicals before you got all the honey. So this is why you are here restricted to this 20-25 days before harvest. And of course, there's one negative effect. You have to find the queen. You have to put her in the cage. And we don't have an automatic system for this right now. But if your queens are marked, and if you are used to deal with this as it is for professional beekeepers, for example, then it's really fast working. It takes just a few minutes, and then it's done, and it's highly effective. And there is one big advantage of this caging method. Colonies get stronger during the period where you cage the queen. And this is because there's still, for the next 3 weeks, a normal brood emergence going on, but there's no open brood to be cared by those young bees. And the effect is they save their proteins, they get long-living bees like winter bees. Those are young, healthy bees which did not care for open brood by themselves. They get long living, and that means the colony really grows and gets stronger, and professional beekeeper like to use this to even improve their harvest in this late period. The negative aspect is you still need chemicals here. And that's why I'm in favor of the last option, and this is what we call trapping comb. And here you cage the queen, but not inside a small cage where no brood activity is going on, but on 1 or 2 combs, like shown here in the picture. And I'm quite sure you know this. Dealers nowadays offer them in all comb sizes with 1 or 2 combs, and there are different systems on the market. So here, in a way, you combine positive effects. What you do is you have to find the queen. You put her there, but then she works on this 1 comb, and there you still have then some open brood where mites which emerge from the previous brood, and most of the mites will go in these small patches of brood which is produced here on those trapping combs. And then you just make sure that you remove those trapping combs from the hive before brood starts to emerge. So it's a question of timing. And if you do so, and over a period of about 4 weeks, so for example, 3 combs sequentially in every 9 days, 3 times 9 days, 27 days, then you take out 95% or even more of the mites. You have a highly successful treatment without any chemicals, and just by taking out 3 combs. And you can even reduce this. Many of our beekeepers now start to cage in the beginning, and then they release after about 2 weeks' time the queen on a single trapping comb, which stands then for another 12, 14 days. And when they remove this single comb, they successfully take out all the mites. So this is really a great system. And I'm sure there are many questions remaining how to use it, and we can discuss those things. But I will even give you some link how you can further study those things. And at the end, it's all those techniques have to be tested by yourself. Do it step by step. Start with some colonies, but start and check out which is doable for you and which is successful under your conditions. In any case, I want to recommend that you combine these biotechnical treatment scheme with the serious control of the given mite infestation levels later this season. That means during August, September, the critical period of healthy winter brood production, you should be sure that mite infestation remains certain thresholds. And the most simple way is to use this bottom board sheets, plastic sheets here in this case. We like to use some oil which we spoil over the plate, and then after short control intervals of 2-3 days, we go and count the mites, and we repeat this every 3-4 weeks. And we go then with a threshold of 5 mites per day. As long as we don't see more than 5 dark mites dropping down per day, we are quite sure that sufficient healthy bees can develop in those hives. And that worked very successfully without nearly no winter losses and strong colonies wintering that way. So this is what I can recommend to all of you. And one option to further learn about those methods and to find answers on all your technical questions may be given in this book, which I wrote together with two of my colleagues from the Institute in Kirchhain, Summer Brood Interruption for Vital Honeybee Colonies. And you find this on Amazon and similar sources. And I think, Flemming, you were going to organize something for the beekeepers in Denmark that way. But this is just one option. It's not advertisement for my book, but it's one option which I wanted to show here. You find much information nowadays in the internet platforms, on the institute sites, and I guess with the Danish Beekeeper Association also. So don't be worried. If you are really interested, you will find the information, and you have colleagues who are already experienced. Learn from each other. Try to organize things on your local apiaries so that you can come together, practice such methods on some hives, get experience in this direction. I'm pretty sure once you started with this and you see how well those colonies can be wintered without any chemical treatment use, you will be quickly convinced that this is a promising way also for you, and you will reduce winter losses and you will have stronger colonies for the next season remaining. So that's so far about the treatment recommendations, and I will add just a few more slides on breeding in a more closer sense. Breeding in a closer sense means really a well-defined breeding program and a standardized testing of colonies. So you have to know what would you like to change on your population, which traits are relevant, honey productivity, gentleness, low swarming tendency as a conventional breeding traits probably. But beside this, we should always check for the mite population development in our test hives, and we can combine it with some further testing for brood hygiene behavior, for SMR, for VSH, those specific Varroa-resistant traits. What we learned is it's not very successful if individual beekeepers do this just with their 10, 20, or even 50 hives. It needs bigger population than that means for us. It needs cooperation of breeders. And this is something which has to be organized. That's why in Germany, for example, we established this Arbeitsgemeinschaft Toleranzzucht, this breeder association. And we have a common method book, and we have an exchange of breeding stock among testers. So each sister group of queens is tested on at least 3 different apiaries, and on each of those test apiaries we have at least 3 different genetic sources to be compared, and this is a basis that we can take all the testing data together, put them in one database. In Germany it's a BeeBreed system, a huge pedigree and colony test database, which is run by colleagues at the Institute in Hohen-Neuendorf, close to Berlin. And they do then breeding value estimation with this. I will not explain right now what is standing behind, but please take the message that this is the most successful way of evaluating those complex informations on genotypes and their performance in the field. And it really allows us to very successfully select better colonies. And in the breeding program, this is combined with mating stations, which you are so happy to have plentiful in Denmark, much better than we have in Germany with all your islands. So I think you have excellent conditions to run such a breeding program, but it has to be organized. And this is something for the people who would really like to go further and collect all the data and have this systematic testing. It's a fascinating activity, but it's not easy, and it needs some experience and it needs some help. Just for you to understand what is selective breeding in a more narrow sense. Still, it's obviously very successful, and I wanted to show this one figure from a European-wide study, which we were asked to run by the European Community or European Union a few years ago. And there we had a 1-year field testing of 20 different European breeding lines. And it was covering all the races: Ligustica bees, Buckfast bees, Carnica bees, mellifera bees, Macedonian bees, and so on. And it's anonymous, so you just see the letters, but those are different lines, and you see the number of colonies which were surviving till the end of this 1-year test period without any Varroa treatment. And here in this figure, it's just shown the average infestation of those colonies per line at the end of this 1-year testing period without any chemical treatments. And I told before about this 10% brood infestation level, and this corresponds with about 3% adult bee infestation level, and that was measured here. This is why you see this red line. So the consequence is genetic lines which remain after 1 year clearly below this red line can be identified as highly resistant. They have a good chance to survive without any treatment around the year, while lines which are above clearly still have a need for additional treatment. And as you can see here, most of the lines, although all of those were before identified by beekeepers as probably resistant, most of the lines were not. They were above. But you see, some of them really were. And this line B and this line D and line, or is it Ypsilon? Those were from this German AGT breeding program. And this line T was one of the German Buckfast lines. And this is very interesting. This was a Polish Carnica line here, by the way. Those 4 lines were below, and all of them had a long history in selection for low mite infestation levels and good hygiene behavior within such breeding programs. So we really see here that with these programs, a good progress was achieved. So it's not only nature which can end up with resistant bees, we can also combine it with our selective breeding. And this is what I wanted to show here. Oh, where we are. I've lost in my... Okay, going back here. Sorry. In Germany, we have quite an interesting initiative now running since 2023. And at that time, the German Beekeeper Association, the Professional German Beekeeper Association, and the breeder associations for Carnica, Buckfast, and so on, they came together and they said, well, seeing the progress in our selective breeding programs and seeing the strengths of adapted management concepts in the sense of biotechnical methods and so on, we really see a good chance to get German beekeeping free of the use of any chemicals within the next 10 years. And that's why they called the program Varroaresistens 2033. And the idea behind is what you see here. On one side, we have the breeders who do this selective breeding, but it's less than 1% of our beekeeper population. And 99% of the beekeepers are here on the right side. They make use of the breeding stock, which is selected by the breeders. But it's mainly the large beekeeper community which decides at the end, by the way, how they manage and keep their colonies, if we still need winter treatment. And if we still have this continuous fruit production over a full season, which ends up with this collapse in colonies in autumn, which gives us this strong exchange of mites between colonies and make all the problems with winter losses and so on. So it's mainly in the hand of the beekeepers, but at the end, those things have to go together. And we are discussing now how we can increase the propagation of selective queen activities, how we can establish more mating stations, or even establish resistance regions where we know all the colonies around are now without winter treatment and have this natural selection effect on for healthy drones, which will make it easy then to widely spread the resistant traits which are identified and selected here by the breeders in the general population. So that at least is our goal, and this is standing behind this project. I would really appreciate if similar activities could be done in Denmark, and I guess we can have a very fruitful cooperation and exchange of those things. I would really like to invite you to share, and we'll end now with a final slide with the most important recommendations I would like to give today to the wider beekeeping community. The first thing is optimize the living conditions of your colonies. And I guess this is what you learn in your basic training courses, which we understand by good beekeeping practice nowadays. Aspects are small apiaries are usually in better health than large apiaries. Keep it small. Disturb colonies as seldom as possible. Keep the natural order in the hive. Always care for good food supply and choose suitable locations and so on. So this is the basis of healthy colonies. Then secondly, introduce this seasonal fruit stop. It's the natural health care of colonies. This is what kept them alive 15 million years on Earth with all the challenges of diseases, parasite, climate, and so on. So this seasonal fruit interruption is really a part of natural disease resistance in honeybees. And I showed how this can be done in principle, and this is where you have to start your personal training and find out what is the best method for you. And do this in time before the rearing of winter bees. And then later the summer season, stay on the safe side. Don't accept this blind flight where you said, well, I had an excellent trapping comb treatment on my hive, so I don't have to care any longer. No, remain on the safe side. Have these short time checks for natural mite mortality, which really ensures that you detect colonies which come under risk in time to get them treated. And then, of course, if you surpass this 5% or this 5 mite per day threshold, then you have to act. But then there are still options for an additional summer treatment, which makes sure that you get healthy winter bees. And if you do so, and if you really winter strong colonies, then you will find by yourself that there is no need any longer to run a winter treatment, as long as you can be sure that in the next season you will come again early enough with the health care of your hive. So if you run again somewhere in June, July, this brood interruption, don't fear if several hundred mites winter in your hives. They don't harm the winter bees, and next year you will come in time to get them out of the hive. That's not a problem at all. But the thing you have to start with is learn how to apply the seasonal brood interruption. And once you see that it works well on your place, then start to think about the winter treatment. We have to come to this point in order to really get the selection for increased mite resistance in the general population. It depends on you, and the winter treatment is a critical point. And then finally, observe infestation differences, and then requeen or selectively propagate colonies. The ones which have low infestation levels, you can easily split up and propagate, and colonies which are highly infested. You may keep them, you may heal them with a treatment, but please selectively requeen them with stock which comes from more resistant lines. And that's a way how you, for your own apiary and within your local beekeeper community, can make sure that you improve the resistance level and that you find a way out of this devil circle which we are in right now, with annual treatments 2 times, 3 times, and still high winter losses and weakness of colonies in winter, which is not a natural and normal situation and which we can easily overcome. And in this sense, I thank you first of all for your attention. I mainly kept the time, it's a bit less than an hour, so hopefully we have time to discuss things. And yeah, I'm keen to get your feedback now. Thank you very much.
Okay, thanks a lot. Great talk. Very exciting. Nice questions in the chat at the moment. And allow me to run over the ones that have been there already. And it's the easiest in my life is simply to start at the beginning. So I will give you a few ones. Yeah, there's a comment actually. There's one of our good listener has been reading Steve Riley's book, Sustainable Honey Bee Breeding.
Yes.
And on page 97, he says he can read that the traits like Varroaresistens has a very low heritability, about 0.1. Maybe it's just a comment, but we know it's very difficult to kind of breed for this. Please give us a comment on this. I mean, 0.1 is actually very low.
Yeah, 0.1 is low. It means at the end, 90% of the differences which you observe among colonies is not due to genetic reasons, but for from other sources, and it's just 10% which is due to genetics. Still, you can select on traits with such a low heritability if you have a large population and do it over a longer period. But luckily, this 10% refers to mite infestation levels. And at the moment where we focus on our breeding programs on the relevant characters, which is a specific hygienic behavior against Varroa-infested cells, which is meant by the term Varroa-sensitive hygiene, VSH, then we come to much higher levels of heritability. We know that this hygiene behavior has a heritability of about 0.3 to 0.4. And this is quite high. It's much higher than, for example, the heritability of honey productivity or even of gentleness traits, which were very successfully bred. So breeders have it in their hands. They can really improve the relevant resistant traits.
Okay, thank you. On one of our workshops, we discussed the question about reinvasion, and you said reinvasion is probably or maybe not such a big problem as we usually claim and very often use as an excuse for not succeeding, let's say, in the treatment or what they're doing. Could you comment a bit on that?
Of course, reinvasion can be a huge challenge. It's not to take it easy. Maybe I was misunderstood in this. I know it from my own apiaries. I mean, I run here 4 different apiaries with my colonies, and one of those is close to other beekeepers, which do not all probably treat their hives, run no seasonal brood interruptions. And on this apiary, I definitely observe higher mite infestation levels and have more problems than on the other ones, which are better isolated. And we know this always in colony crowded areas, the problems are bigger, and this is due to this reinvasion, or mainly due to this reinvasion. So it's not easy. But on the other side, you can successfully select for resistance on your smaller apiaries, even if you have other beekeepers around which don't do this. So this is, for example, something which we can learn from Steve Riley. I was not convinced in the beginning if he with small apiaries can manage this, but he did. They were quite successful. And yes, I agree. Often we claim that reinvasion is the reason why we get problems with some of our hives in late autumn, and we easily overlook the exponential growth curve. And probably there were too many mites before, but you just did not notice in time. And that's why I strictly recommend have this at least 2 times, maybe 3 or 4 times, check for natural mite mortality starting in August, September, in this critical period, just to keep it under control.
We have a lot of practical questions. There is a question about, I think it was the total brood removal, so to say. What do you do? I mean, are you reusing the brood frames? Do you dare to reuse the brood frames? So what do you do with them? Are they get it melted or
Yeah.
What are you doing with them?
Yeah.
Those frames.
So total brood removal, and probably the same question would occur when we talk about the trapping combs. So what to do with those combs which we take out together with mites inside? Yeah, one easy way is to just melt them. Throw them away, take the wax. But be careful. This has to be done very quickly. Otherwise, after a few days, they start to rot and to stink, and it's not fun at all. And if you make total brood removal, it's plenty of combs. So yeah, if you just have a few hives, you may manage. But otherwise, it's a challenge. So usually, it's much easier to put them in a separate hive together with some adhering bees, of course, just enough bees to keep the brood warm enough so that the bees can emerge, and put them on a separate location and just wait for 3 weeks time so that all the brood is gone. And at the moment where you get these empty combs, you can easily see old combs can be taken out, can be then easily melted, and you have time, you're more flexible then because they don't rot, just keep them cold. You can melt them in winter if you like. And if you have light combs which are still in good shape, or food combs, you can use them further on. And if you let the bees emerge, then you may see that not too many bees are remaining because they were already so heavily infested with viruses and with mites that it's not worse to keep them alive than kill the bees. But very often you are surprised how much bees remain after these 3 weeks time. And then this is a starting point for the buildup of new colonies. So take the bees, use the moment where all the brood is gone to run a one-time treatment, for example, with oxalic acid. So you get rid of the mites, and then you have the bees, and you put them. They are capable to rear their own supersedure queen, or you may introduce a new queen and then start to feed them, put them on new combs, and until autumn they can easily develop into additional healthy colonies. So the experience is 2 colonies with total brood removal usually end up with 1 additional colony built from the combs which you took out and which you treated in the way as I just described. So you make out of 2 colonies, you easily make 3. And yeah.
Okay, but you have to be careful with the broods, depending on how many mites there are in the colonies. But yeah, okay.
Yeah, sure. Yeah.
Yeah.
That's why you should put them separate. And
yeah.
at the moment
Yeah.
where the brood is gone, immediately treat them.
Yeah.
Don't. Yeah.
Okay. We have a question from Jesper. And Jesper, sorry, I tried to cut you. You're really good at making questions. Thanks a lot. And they're monitoring in a school apiary, and they try to do it regularly. Do we have a table or a graphic that are showing if you take the natural mite fall over the year, so that you could say, okay, we count mites, let's say the 1st of May means this and this, or
Yeah.
and then we count to another time, okay, we have to be careful. Do we have good documentation of this over the season?
Yeah, there is a what we call working sheet on the homepage of the Bee Institute in Kirchheim. So we always used it. Basically, it's a logarithmic scale because we know that we have this exponential mite growth. It makes sense to mark your infestation levels on a logarithmic graph. And then you end up with a linear increase, yeah, if you have this logarithmic paper. And with this, it gets much easier to see if there's a different mite development. If you at the moment where you compare hives, some have a steeper increase, some have less increase. So that helps in the selection. And at the same time, you can earlier the season check where may I end up in August, in September. So it's really like an early warning. Fleming, I don't know if you have a similar working sheet, or if perhaps I can send it to you, or you find it on the homepage.
But
so
we will
it
find
could
it on the
easily,
home. We'll find it on the homepage, and then we will send a copy
otherwise,
to everybody, and maybe we'll make a translation actually.
Yeah. Otherwise, let me know. I'm ready to help you in this.
Okay, thank you.
It's really useful if you have such paper at hand.
Yeah. Then Jesper again, thanks again, Jesper, and thanks having your name visible. So we really talk about Varroaresistens here now, but all the time when we talk about on the way to make Varroaresistens, we have to do this root removal, trapping, or something like that. But when you talk about Varroaresistens in your own bees, you don't treat anymore. That's the goal. But we all the time when we talk about this, also other places and so on, we always talk about don't make a winter treatment, but make a summer treatment, and make a brood interruption. And for me, a brood interruption is also a treatment in some way. So are we at that place that when you follow your recommendation, at the end you don't treat at all? Anything?
Yeah. So, I mean, it's a very good question and something to discuss. I hope that I could explain why this winter treatment has such a critical meaning. As long as we run winter treatment, we equalize all the colonies with regard to the next year's mating period. So even highly susceptible colonies get a chance to produce non-infested drones in the next season. And this is then the way how genes which make colonies susceptible are again spread in the open mating. And therefore, this winter treatment has a very specific meaning. And when I suggest these biotechnical treatment methods to replace classical chemical treatments, then it's because it gives us a much bigger flexibility in the timing. So you can use these biotechnical methods already in June or early July. In any case, early enough to ensure that the colonies afterwards rear healthy winter bees. So in this sense, the use of biotechnical methods is an important bridge to overcome the need of a winter treatment. And please understand it as a development for the beekeeping community. Let's start with biochemical methods to reduce varroa timely, to get healthy winter bees, to skip any winter treatment. And once we come to this standard, then we have a strong move that the more resistant colonies succeed in the open mating process, and resistant genes can easily be spread. That's the story.
Okay.
Of course, Jesper is right. The final goal is to find colonies which can do completely without fruit interruption and all those things. And we know those colonies are there. Some of the breeder had such colonies. I have shown you the results from this Your Best study, which showed that there are several lines remained with the average of all those colonies below the threshold values. And this was completely without any treatment and any fruit interruption. So of course, this is the final goal and we will end up there. But we have to see the process. And that's why biotechnical methods play a crucial role at the moment. And even from the point or from the point of view of breeders, I can tell you, since we only use these biotechnical methods, it got so much easier for us to see the different susceptibility levels between hives. Because if you really keep them from, let me say, mid of July for a whole season without treatment, then you easily see in May, June next year which colonies still have no mites at all and which come close to this critical threshold level where they urgently need a treatment. You can much easily observe it compared to what we have at the moment, 2-3 times treatment per year. If you treat all your colonies in December, you won't notice big differences between resistant and susceptible lines in May, June next year. You just overlook it. And then you learn that in July again, at the moment where all the honey is taken, you have to treat again. And then you treat all the colonies. And you never see really distinct differences. But you will immediately start to observe this at the moment where you rely on biotechnical methods. And then selecting gets really fun because you will be so proud that some of your colonies do well without. And that's the one which you propagate.
Yeah, I can tell you I made what I call a small crash test this year, and I am so with no treatment, and I'm surprised about the differences really. And just to give you everybody just a small, I went to Wales this summer. I just wanted to see those populations in England and actually in Wales, And I met the people and I saw the colonies, and they don't treat. It's really. I can really recommend people to go to Wales and to England and find some of those people that are not treating at all. So they're really at the point where you are.
Mm-hmm. Yeah.
Now there's from Jesper Kirkegaard, and please Jesper, rephrase your question if I am misinterpreting your question. But at least in Danish queen breeding, we have really been breeding for not swarming, and I have great bees at home, and I do even not check for swarming in my colonies. Are we going too far? Have we been gone too far? I mean, are we promoting? But in this breeding, I mean, goal that we got there, and they're really good, the Danish bees. They do swarm if they have to, but mainly they do not swarm. Have we done too good, too well? Is it, yeah. And Jesper, please rephrase your question if I totally misunderstand this.
Yeah, very nice question to discuss. I say no, we don't have gone too far, because we should have a realistic picture of what we are. We are beekeepers. We want to produce honey. We want to serve with pollination activities. That's our task. We are farmers in a way. We are not natural protectionists. I know some people misunderstand this nowadays. They want to have some bees just to help the nature. Okay, you can do this, but that's not what I'm going for. To be honest, I want to make honey. I don't want my colonies to swarm. I don't want to get stings. And I'm happy that I can say we have highly productive lines which don't swarm, which don't sting, and still go without my propagation.
Yeah.
Yeah, thankfully enough, it's different traits. VSH has nothing to do with defense behavior, with swarming behavior, with honey productivity. So we can combine those things. Still, Jesper is right in the sense colonies which swarm do better with Varroa and other diseases. And so my understanding of beekeeping is at the moment where we affect such natural behaviors which play a role in the sense of health and vitality, then we have first of all to recognize this, to understand this, and in the next step to think about the consequences. How can we compensate this? And when I explained before these technical methods of brood interruption, this is compensation. We give back to the bees what they would have with the natural swarming behavior. We prevent swarming to harvest more honey and to have stronger colonies. But then it's at the same time our obligation, at least for me, that's how I understand my beekeeping, ethical beekeeping, natural beekeeping. Then it's my obligation to compensate this by an artificial brood interruption.
Yes. And now Grete, hello Grete from Samsø, a small island, or a rather big island here in Denmark. She met a beekeeper, and she's thinking, I mean, actually taking your talks, and she's thinking about how can I make a brood interruption, and of course she's rethinking it, and I think this is also great within beekeeping. We all have our own methods, so she's relatively early, or maybe not early, in June or July, making artificial swarms.
Mm-hmm.
So brood interruption, and then when she gets later to the season, as far as I can see, she tries to unite the colonies, and in that way she keeps the number of mites low in the colonies. So she kind of make her own best practices how to run this. I hope I understood it right. Then, because time is running, and thank Grete, Paul Erik from Viborg, viruses. What he's talking about, you know, the Malas Bivak, all the talks about viruses, and you could say the antibacterial properties of propolis. Is that in your mind that we should breed for bees producing more propolis. And again, I can give you an example in Denmark. Definitely over many, many years, we thought we don't like propolis. So we were actually, I don't think the breeders did it by purpose, but it was gluing and everything, and it was difficult to take the frames. And so I think we a little bit did breed for colonies, bees that were producing less propolis. Should we do the opposite?
I cannot finally answer this from a scientific point of view because there are not sufficient studies as far as I see. And we never compared it. It may be true, yeah, it's a very interesting aspect. But I guess it's not the most important thing. And this is because we have seen in all those resistant populations throughout the world that Varroaresistens always goes hand in hand with low numbers of mites. I don't know a population where you observe really high mite infestation levels and still those bees don't suffer because there are no viruses for whatever reasons. I don't know this. So far, what I'm aware of is always this very close correlation between Varroa and virus infestation levels. And also we know that at the end, bees suffer more from the viruses and die because of the large virus amounts. It's a mite which opens the door and which is mainly responsible for virus development in the hives. So if there are some effects of propolis on virus infestation levels, then probably they are limited in the effect. So this is what I know so far, but as I said, I don't feel well to finally answer this with some scientific reliability. Yeah, sorry.
Okay, yeah, but that's great. And then now we take the questions rather fast. Again, I shot a question down here. We really did that in Denmark, or some of our breeders. They went to, let's say, John Kiefoos, bought some queens, resistant queens, took them to Denmark. They were crossed in, and the short story was that we never felt that we could buy the Varroaresistens from somewhere. Could somebody do the work for us? We buy it. It seems kind of when we're moving the resistant queens or bees from one place to another place like Denmark, high explosive, aggressive Varroa mites. I don't know. Please comment on this.
No, fully agreed. We made several times exactly the same observation in our scientific studies. We had a large-scale European exchange experiment about 15 years ago, and it's all published, Journal of Apicultural Research. And we found exactly the same. We took bees which are supposed to be resistant in the south of France and in Poland and everywhere, and we brought them to other places. And at the end, none of these lines were resistant all over. And sometimes it was just the opposite. For example, I also had bees from Avignon, which did very well in the hand of Yves Leconte in Avignon. No treatment since 20 years. We got them to Kirchhain. At the end of the year, it was the highest infested line. And we put this all together. There is a very strong interaction of genotype and environment. And if we say it's a resistant population, then we mean bees which are well adapted to the local climate, to the local setup of parasite and diseases, to food storage, food seasonality, and last not least, beekeeping manners. We should be aware that we affect quite a lot these disease developments by our management techniques, and all this has to be put together. So there's a very clear conclusion from all these findings selection for resistance has to be done within your local populations. You may profit from certain imports. So if you go to improve VSH trait, for example, you may have some success with well-selected VSH bees from somewhere else. But then you have to cross them with the stock which is available on your front, and you have to test it at least 2-3 generations to be sure that the bees really have all the behaviors, all the adaptive capacities which are needed under your local conditions, combined with increased VSH.
Yeah.
Yeah. So don't trust any long distance imports. It never works. It's just increasing your problems. Stay with your local stock. Make a careful selection on the spot, and that's what helps.
Right. So you just lost a lot of orders from Denmark. No, but you're right. Yeah. There are questions, but we need to go to an end. Ole, also, please. So there was a suggestion here that actually, and this is what the old heather beekeepers actually did when they came home from the heather. They wanted to have the heather honey because it had such a high value, and they actually removed all the frames. There was not a lot of brood at that time, and then they put them on totally new frames. And could it potentially, could you make a trapping there? I mean, because the winter bees are done, we're talking about late September or something like that. Take the heather bees home on new frames, and then a trapping comb in the middle, and then kind of suggest. I think that's a suggestion for trapping mites, at least as I understand it.
You could try, but in this very late season, trapping comb technique is not working perfectly, because as later the season, as more of the mites will remain on the bees, so they slowly switch to the winter period, and more mites remain on the bees, so the attractivity of the brood is going down. That's why if you have a high infestation level, it's clearly better to have a chemical treatment at that time when you come home from heather, and then just brush off the bees. But what I would clearly recommend for people who use a late heather flow, cage your queens during the last 3 weeks of the flow. Yeah, to have an earlier brood interruption, and then you may immediately treat them when you bring them home, or in this period with still a good pollen flow from heather, you may trust on a trapping comb. So it's a good chance to put the queen on the trapping comb, as I have shown it, and make sure that you remove those trapping combs before bees start to emerge. And then probably that would work. I think that is a good advice for people using heather honey. To be honest, I never did it myself. We don't have heather here. I don't have this very late flow. So personally, I have no experience with this, but I know from professional beekeepers who run similar strategies with quite a good success.
Okay, thanks a lot. Time is running out, and I have to admit, there are 2 questions out there that Ole and I really do not exactly understand them. Please write to Ole and me, and we will take up the questions again, and then we will talk with Ralph and see if we can answer it via mail communication. Ralph, thanks a lot supporting us and being willing to come here. And I'm sorry that came just a question, but we will not take it. Thanks a lot supporting us, and let's keep closely in contact and cooperate, because this is very important for the future. Ole, some final comments before we give Ralph the very last word.
Yeah, I think we covered it in more or less all of it, and of course the question is it's difficult to really to have them all in there, but it has been very interesting for sure, and inspiring. As I can also see several comments coming here that they're very happy about the talk. So please.
Okay. Yeah, great for me to hear. So thank you very much. I'm really happy that you are so open for this. I mean, you asked for this and you pick up those ideas. So thank you very much for this. And of course, I'm ready to help whenever I can. If beekeepers start and problems arise, please let me know. We can discuss on this at any time, and hopefully you have some good experience with this, some success, and then I'm happy to come again earlier or later to see how the Danish bee population slowly moves to resistance.
Yeah.
So
Wish you good success.
we will be examined. Thanks a lot,
Yeah.
everybody. Ole, when will we have the recording out? Maybe already tomorrow?
Tomorrow, I think.
Yeah,
Yeah.
okay.
Yeah.
So, and we will send a mail out to everybody, and this Varroa counting sheet, we will also try to organize it. And so, everybody, thanks a lot. Ralph, thanks a lot. Great talk.
Thank you.
We're so happy.
Okay, great.
Bye bye, everybody.